All right. Well, hopefully you feel okay about the exam. I don't think it was one of the hardest, but you will be the judge of that. So next we're going to talk about emerging and re-emerging infectious diseases. Gosh, here are some examples of emerging and re-emerging infectious diseases. And this is not a full complement of diseases that are emerging and re-emerging. Um, So, sometimes we think, oh, we've got cures for everything, antibiotics take care of everything. And the sad part is that some of our antibiotics are no longer working. And then there are diseases all the time that are appearing. So, for instance, we talked about cholera, and cholera is reoccurring. And so is influenza. Anyway, on this, you can also see there are re-emerging diseases that we had cures for. For instance, diphtheria, and as I mentioned, cholera. There's also listeriosis. Those are all bacterial, typhoid fever or typhus. Anyway, you don't need to know all of these. I'm just saying, I just want you to realize that there are diseases that occur all the time, and some of them are really bad, and some of them we've seen before, which are the re-emerging, which we thought we had a handle on, but apparently not. So emerging infectious diseases are those of a previously unknown disease or a known disease that's rapidly increasing in incidence over a certain period of time. So like there might be one case or two cases of this, and it's been seen over several years, but then all of a sudden it's starting to become more prevalent, and so that would be an emerging infection, even though we've known about it for a while. And then also a persistence of an infectious disease that can't be controlled. And what I mean by that is that there are, like, let's just take cholera. Well, no, that's not it. That's a re-emerging disease. Just another, like an example of something that we've known about that can't be controlled. Let's say E. coli. So we know about it, and we can control it if we uh, take care of people, and also get rid of cattle that are infected with it or whatever. But maybe it's going to switch somehow, and then it's going to start emerging in other people and other populations in other parts of the world, etc. So that would be emerging. And re-emerging diseases, I've mentioned some of those that reappear after they've been on a significant decline. So a huge example of that one would be smallpox. I mean, smallpox is theoretically gone, but if that were to come back into vogue, or come back into infecting people, I don't mean vogue, then that would be a re-emerging disease. And as you saw, cholera is a re-emerging disease, and so is typhus or typhoid fever. And then as antibiotics become less and less effective, or if they do, then we'll see more re-emerging diseases. So to talk about the numbers in a little greater detail, there's 335 emerging infectious diseases identified between 1940 and 2004. I think we can bump that number up to at least 350 now. But the majority of these originate from wild animal reservoirs. And as climate change takes hold and animal populations are forced to come nearer to us, or we're forced to go nearer to them, emerging diseases will be more and more prevalent. So what are some of the diseases that we've seen? SARS, MERS, which is Middle Eastern Respiratory Syndrome, Ebola, and you might have heard in the news that I believe it is, well, I don't want to say, but one of the African countries is now having an outbreak of Ebola. Another disease is called chikungunya. And then also there's the avian flu, the swine flu. Those are influenzas, Zika virus, and then SARS coronavirus 2, which you are familiar with. All right, so why are diseases emerging or re-emerging? Well, one is what I mentioned, climate change is making people go to different areas and animals go to different areas. There's also increased global travel. Some of the diseases we see in the United States now have only been found in other countries, but now they're coming back because people are traveling and bringing them back with us. For instance, tuberculosis was uncommon in the United States. And then there were populations of people who were coming over from different areas. I think Southeast Asia was one. And so there were people coming over with tuberculosis who then infected other people. It's not all bad. In most cases, we've been able to take care of those. But that does. Hi, sorry, gotten a couple of texts from my daughters and then calls, so I apologize. So let's get back to this slide. Why are there emerging and re-emerging diseases? Well, there's increased global travel. And as I mentioned, people are going to more remote areas and animals are going to more populated areas. And then sometimes people go places. You remember the story I told about my daughter and her not taking her medication for malaria? Well, a lot of people don't even think of that. And they just go. They don't think of what they might get, or, they might be in, in like there was just a hurricane or a couple of hurricanes in Florida. So, what if the water got contaminated, the drinking water supply? So then that could cause, cholera, or could cause, other diseases. That's just another reason. And then also with the global food market, we transfer food all around the country now. It isn't just local. It isn't even just across states. It's all around the world. So that too can cause some increased infectious diseases. Okay, let's go. All right, so what else happens? There's an evolution of the pathogen over time. Pathogens mutate and then they change, and we're not able to treat them in the same way. Or climate change, as I mentioned, vector changes. It might jump from one animal to another, and then like it gets into a domestic cat, and then people who have cats are more at risk. I mentioned antimicrobial resistance. So that's organisms that develop resistance to antibiotics. And then diseases can also spread in healthcare facilities. So you go in for one thing, but you get something else, which is not good. And then we have an aging population, and so we tend to get more diseases. People don't get vaccines, or not all people don't get vaccines. A lot of people don't get vaccines. And then also there's countries that just don't have the funding for vaccines. So those have an increased disease presence, which then translate into more disease worldwide. As I mentioned, environmental contamination, from like a hurricane or something, poverty and social inequity. That's a biggie. We're a rich country, and in most parts of the country, we have really good access to healthcare. And in some of the rural areas, we don't have as good of access, but it's still far superior to what healthcare is available in some of the really, really poor countries. Okay, what else? Zoonoses. So a zoonotic disease is a disease that's transmitted from animals to humans, either through direct contact, food, water, environment, whatever. So there was a case once of a family that got strep throat. You've probably all heard of strep throat. And then they got antibiotics. They all got better. Then they all got it again, and this happened a couple more times, and the doctors were like, what the heck is going on? So finally they swabbed the dog's throat, and the dog had it. So they had to treat the dog, but that was a case of a zoonotic disease. It was transferred from the dog. Now that's not a typical kind. The typical kind are diseases that occur in animals that are then transmitted to humans. 61% of infectious organisms affecting humans are from an animal. And that can be an insect, as we saw with malaria, or it can be a cow, or anything. So here are a couple of examples. So if we look at the very left-hand side, lower corner, stage 1, that means the agent is only in animals. So we don't get it unless we get a bite from an animal. And in this case, we're looking at rabies. right? Everybody knows about rabies, and you don't transmit it to anybody. It's only found in animals normally, different kinds of animals, but still only animals. And we can get it just from a bite. The second type is a stage 2, stage 3. And that example is Ebola. And that means that animals have the primary infection, and then we have a limited outbreak in human populations who get it from the chimpanzee or the monkey or whatever. Then we have the third stage, third or fourth type, which is an example is dengue fever. And you'll cover this a little bit later on. But dengue fever is originally in animals, then it spreads to humans, and then humans can spread it to other humans. Okay. And then we have the final one, which is HIV, which originated in primate populations. And then it infected humans, and humans can also spread it to other humans. Okay, so several different ways that zoonotic diseases can infect us. So what are some of the emerging infectious diseases? Well, the ones in red are the ones we're going to talk about here. Most of them in black, we have covered or will cover in the weeks before and the weeks ahead. So we're going to talk today about Lyme disease, hantavirus, West Nile virus, monkeypox, MERS, SARS, Ebola, and chikungunya. So let's get started. Here's some re-emerging infectious diseases that will be covered in the next lecture. Okay, this lecture is really one lecture, but I broke it up into two just so it's, there's a lot of diseases in there. So I thought it might be a little easier to absorb. So what are some of the re-emerging infectious diseases? Well, you can see the list here: malaria, tuberculosis, cholera, pertussis, influenza, and gonorrhea. We are only going to talk next time about pertussis and gonorrhea. We've covered malaria, tuberculosis, cholera, and influenza. So you know everything about those already. So, all right. So here's just another way of looking at it. Emerging diseases on your left, re-emerging on your right. All right, so as I mentioned, Lyme disease, hantavirus, West Nile virus, monkeypox, MERS, Ebola, and chikungunya. So what's the common ingredient in all of these? They're all viruses. Ooh, boo, I hate viruses. Viruses are bad because they can cause such severe disease, and we have such limited treatment for them. So they bug me. All right, you've probably heard of Lyme disease, so we'll start off with the easiest. Lyme disease is caused by a bacterium. Oops, this one is by a bacterium, sorry. And it's transmitted by the deer tick. So the deer tick gets it. And then when the deer tick bites you, it ingests some of its saliva into your body, and you get a bullseye rash. I don't know if you can see that here, but there's a red round circle in the inner side. The inner circle is kind of a lighter color of white. So this is caused by a deer tick, and the deer tick is even smaller than a regular tick. I think most of you have seen regular ticks, but this one is even smaller. There's a comparison there, not quite exact, but close, where you have a deer tick next to a dime. So it's super tiny, okay? And it's common in grassy and wooded areas. And just like other ticks, it kind of hangs on the blade of grass or, whatever. And then when someone walks by, jumps over and then attaches to you. So you got to check your animals and check yourself when you're out in the woods to see if you had any ticks attached to you. Hantavirus. Hantavirus is found in North and Central America. In the United States, it's only west of the Mississippi River. It's very common it's common in Phoenix. It's common in New Mexico. Anyway, the deer mouse is a carrier, and it is a respiratory disease. So you get it by inhaling mouse droppings, not droppings themselves, but, stuff from their droppings. Or you can get it from a mouse bite or from a scratch. So you want to stay away from rodents and not feed them ever. And because this one can be pretty fatal, 38% fatality rate. So that's, 40% is approaching almost half and half. So yeah, want to stay away from that. There were 833 cases in the United States last year or the year before, I'm not sure which, I think last year. So it is an emerging disease. We'll see what happens with this one if it gets more prevalent. This is where the cases of hantavirus were. If you have the dark orangey or dark redder area, those are greater than 50 cases. In the lighter, we're still kind of orangey pink, that's 16 to 50, and then less than that in the other areas. Deer tick, just like most insects, is specific to a certain kind of animal, and it's likely that animal, this is, the West Coast is where that animal is more prevalent. So here's a guy, and he's sweeping up some junk in his driveway or in his yard, and there have been mice around, and they're just putting their droppings out, and then he's inhaling some of that hantavirus that was in their droppings. All right, West Nile, you've probably heard of this one. A couple years back, this was probably more like 10 years, not a couple, a decade ago. So this was really showing some emergence. And then they really tracked the birds and tried to eliminate birds. And, oftentimes birds died, but anyway, and it kind of died out a little bit, but it is still considered an emerging disease. It's transmitted by mosquitoes. Mosquitoes bite a bird, and Sacramento has tons of magpies, and magpies are one of the commonly infected birds, or crows also, even house sparrows, and bluebirds or blue jays. Anyway, the mosquito gets it, and then it will bite us. And in the United States, there were 52,000 cases, so not great, but the fatality rate at least is a little bit lower. But it can cause, an illness. And at first it was hard to recognize, but doctors are much more aware of it now and are, able to diagnose it a little more readily. There still is no cure or anything. Remember, it's a virus. So, and climate change may have a large effect on this because we may be closer to birds. Birds may be closer to us. Different kinds of birds may be closer to us. But this one is expected to have a large effect. And also, there may be more wet areas in the United States, so more mosquitoes. And monkeypox, you've probably heard of. This has been in the news recently. Monkeypox is transmitted by direct contact. It's a virus, obviously, monkeypox virus. It's by direct contact or by touching an infected surface. So, like if you're on someone's bed sheets or you sit down right after them with your shorts on the couch, or, things like that. There's a few cases that have been airborne, but that has only proven to be in cases where you have very, very close contact. It's in the same family as the smallpox virus, and it came from Africa, came out of monkeys, obviously. It is endemic in Africa and 45 other countries. So air travel from Africa triggered the outbreak, we're currently having. It started showing up on the East Coast, and then it's kind of found its way out here. You can get a vaccine, which is the smallpox vaccine, because it is from the same family. The smallpox vaccine does work. But as you may recall, the smallpox vaccine has some side effects. And so they don't like to use it unless you're pretty sure you're going to have close contact or you're at risk. So it's not given widely. They're not, rolling out the smallpox vaccine for everybody to get yet. Hopefully never. And this is what it looks like. The image on the left is a pretty severe case. The pustules are very small in size. They're just kind of starting out, but it is, as I mentioned, a fairly severe case. On the right-hand side is what the pustules look like when they're fully developed. You can see they have kind of a pus-filled center round along the skin line, and it takes them a while to go away. And like I said, there is no cure. In most cases, the patient just recovers from it, and it's uncomfortable, but anyway, less fatalities. MERS is a coronavirus, and it is very similar to SARS and to corona or COVID, one that caused COVID here. It started in 2012 in Saudi Arabia. It was 30 to 40% fatal, which is actually somewhat similar to coronavirus. Coronavirus was more like 10 to 15, but it is can be fatal, and it affects the same type of people in a bad way that coronavirus did. Those with diabetes, those with respiratory disease, heart disease, kidney disease, etc. Symptoms usually show up about a week after exposure, just like COVID, 5 to 7 days ish. And then, but it ranges up to about 14 days. In treatment also is just supportive treatment. It's a virus, no treatment. And so, anyway, this is an emerging disease, but it's not rapidly spreading. So, and I haven't checked to see what the current numbers are in the Middle East, but I don't think they're high. And then here we come with the big ugly guy. It's a virus. You can see it right there on the lower right. It's a big, huge virus. And it's a big, mean virus. It kills a lot of people. It kills 25 to 90% of those who actually contacted. So in last year, I think it was, last year there were 28,000 cases, 11,000 in Guinea, Liberia, and Sierra Leone. There were 36 cases and 15 deaths out of Africa, but most of the cases are in Africa. Why is that? Two reasons. One, we get it from it's the natural host is a monkey, and so in Africa there is much more contact with monkeys, and also many Africans eat monkey meat, and if you eat monkey meat, then you can get Ebola from eating that meat. It's not necessarily killed in with heat, so it can be transmitted. Also, there are some religious practices in Africa that when a person dies, people may eat a portion of them, a part of their brain or a part of their heart to keep them with them. And in doing so, they may become infected if the person has died of Ebola. In the United States, there have only been 11 cases. 7 people came from Africa, and 4, the virus was transmitted to healthcare workers. No deaths, luckily. This is a nasty one, so we don't want that we want it to just stop. That's what we want. We don't want it anywhere, anytime. All right, Chikungunya virus. This is another pox-like one, but it's done by mosquito transmission. It's very similar to dengue fever, which you don't know about yet, but you will. It's found in Africa, the Asia, and the Indian subcontinent. So kind of those warm areas of equatorial areas. There was a major outbreak in 2015, which affected several countries in the Americas, mostly South America. And then in Italy in 2017, there were 436 cases. Severe cases and deaths are rare, but climate change is likely to increase the endemic areas because of climate warming. And like I said, it affects kind of that equatorial area. Well, as climate change happens, that warmth is going to spread up and spread down. So here are current and previous local transmission of Chikungunya virus. So you can see, for the most part, it's kind of in that central area. But as climate change happens, like I said, it's going to spread up and it's going to spread down. Warmth, and probably with it, the Chikungunya virus. All right, so here is what it looks like. It's kind of like a measly, or not really poxy, but, kind of, red dots, whatever. The bad thing about this is it can affect your central nervous system. And if that happens, then you are more likely to die. And you can have multiple organ failure, and it can kill young people and old people. Over on the right, we have how it affects people. 25% of people who are infected with Chikungunya have confusion and syncope, fainting, etc. 19% have headache. 34% have difficulty breathing. 43% have heart attacks. And 6% have renal failure. So not something you want to get. Even though a lot of cases aren't fatal, those are some serious consequences. So heart attack, yeah, no. Renal failure, yeah. So that means a kidney transplant or dialysis. So anyway, not a good disease. All right, so we are going to talk about reemerging diseases now, and primarily 2 in particular. These seem to be fairly common as far as coming back. So those are two good examples to talk about. The first one is pertussis, and that is whooping cough. And it's called whooping cough. I think I have a link or a little video of this, but it's basically you go and you're having trouble sucking air in. Oops, shouldn't have done that. But anyway, so it's kind of like a big wheeze in because you're having trouble getting air. And then gonorrhea, you probably all know, is a sexually transmitted disease, a bacteria. So yeah, you don't want that either. All right, so whooping cough, there is a vaccine, and it's been most people have been vaccinated. However, they have found that the vaccination rates have declined. There's an anti-vax movement, and a lot of people were afraid that this was causing, illness in children. There was some report. There was a discredited doctor who theorized and published a paper saying that vaccines were causing autism. That has been debunked, and he has been disbarred or just whatever, dedoctored, because it did cause a lot of upset people. But there is no problem with the whooping cough vaccine or any other vaccine so far. Also, the vaccine that we use is now an acellular vaccine. So before they used actual cellular components of the Bordetella or the pertussis bacteria, but now they're using just smaller fragments, and so they think it's less effective. And then also the strain of Bordetella may be slightly different now. So for all of those reasons, that is why the disease is reoccurring. It is spread by airborne transmission, and there's over 100, maybe even 200 cases reported annually, and probably another 50, 200, I don't know, a lot of cases that go unreported because most people just think they have a bad cold or something like that if they're an adult. You do get inflammation of the respiratory tract. And as it says here, it interferes, or as I have said here, it interferes with clearing of your pulmonary secretions. So you can't get out, the fluid, the mucus, et cetera, that's built up. And so you're coughing really hard and frequently. As I say here, 48,000 in the US, but many more diagnosed unreported. I actually had this about 15 years ago. I went to the movies, and I think I was watching Braveheart. So maybe that was even longer. I don't know. But anyway, there was a person about 5 or 6 rows behind me who was coughing up a storm. I mean, I remember many of us turned around to look at her like, are you okay? Well, about a week or two later, I got a cough. And I was having the whooping and the wheezing and all of that. And so I was diagnosed with pertussis, which I'm certain I got from the person in the movie theaters who was less than thoughtful by exposing an entire movie theater to pertussis, some of whom vaccines had probably worked beautifully. Mine had worn out, no doubt. I'm an older person, so, they don't last forever. So I was given antibiotics and, recovered just fine. All right, so here is, oops, what's going on? Okay, sorry, it looks like my screen sharing was doing something weird. So here are whooping cough vaccines when you get them, and most people have them. So you get a Tdap vaccination, which is diphtheria, tetanus, pertussis. It's a combo, 3 vaccine. You get that, or you did get it probably at 2, 4, and 6 months. Then you also got it at 15 to 18 months, somewhere around there. And then you got it again when you were about 5 years old. Okay, that's the normal schedule. And then you typically get it when you're a preteen, 11, 12 years. You get it during your 27th to 37th week of pregnancy. And then typically you get it about every 10 years. Most doctors recommend you get it about every 10 years. It has tetanus, the tetanus vaccine, that portion of it is why they recommend it every 10 years, because tetanus they know for sure can wear off. So they do recommend that. And if you, cut yourself on something or you step on something, then you cut your foot, they recommend you get it, right then, especially if you haven't had it for, or you can't recall when you had it last. So here's another one, pneumococcal disease. I didn't have this at the very beginning, but this is caused by Streptococcus pneumoniae. This is a bacteria. It gets into your lungs and can cause pneumonia, and it can also cause sepsis or meningitis. So sepsis, remember, is when you get it in your blood, and meningitis is when you get it in the coverings of your brain and your spinal cord. It's airborne, so this is common in winter time when people have coughs. I think it's a cold, and typically it is a cold, and then you might get pneumonia afterwards. Your lungs and your body gets more susceptible, and then the bacteria, if for some reason you have it in your throat, which some people just carry it normally, can get into your lungs and cause disease. It causes high fever, chills, cough, shortness of breath, chest pain, stiff neck, disorientation, and sensitivity to light. The most common, of course, are fever, chills, shortness of breath, and chest pains. There is a vaccine for it, and you can be treated with antibiotics for it. So if any of those symptoms show up, go in and see your doctor. So here's another one, gonorrhea. So this went away due to, or was well controlled, very well controlled in the 40s, 50s, and 60s, because well, in the 40s, it kind of became, it increased because a lot of men were traveling during the war and frequented bordellos, etc., and brought back gonorrhea with them. I mean, not, not unusual. But and then it went away, but now there is a drug-resistant gonorrhea. And also people are less aware. And so they may get something and not think it's anything and just continue to have it. But the most have developed resistance to all but one drug. And the CDC thinks this is an urgent public health threat. And as you know, it is sexually transmitted. So, and caused by a bacterium. So why does drug resistance happen? Typically, it's one of these or a combination of these reasons. So a doctor may select an inappropriate antibiotic. So there's certain antibiotics that treat one type of disease, another type that treats another type, another third, fourth. So there's, you have to treat a bacterium with the right kind of antibiotic. Otherwise, it's just not going to do anything. And then by that antibiotic being in your bloodstream, this bacteria can develop resistance to it. And remember the plasmids that the bacteria can transmit from one to another. Well, if they develop resistance, they can transmit it to somebody, another bacterium who needs it, who we don't want to have. So we don't want to give the incorrect type of antibiotics. The same holds true for overuse of antibiotics. If you don't really need an antibiotic, then the same thing can happen. And also poor quality antibiotics. If a drug manufacturer, has an error in their formula, or you're getting, some from Mexico or, I don't know, some other place, the antibiotics may not be as effective or as strong as you'd like them to be. And then the bacteria can develop resistance to that. And then there are just normal genetic mutations within organisms. And they just, they reproduce frequently every 20 minutes or so. So, they're going to have lots and lots of mutations, and their DNA is very small compared to ours. So, just by happenstance, they're going to develop a mutation that has resistance to a certain certain antibiotic on it. So that just happens, over time. Also, we have unrestricted access to antimicrobial products, and this is something that I really don't like. So here are I just did a Google search on, Amazon search on antibacterial. And these are the things that have antibacterial agents in them, or antibiotic-like substances in them. So soaps, detergents, hand lotions, window cleaners, cleaning cloths, surface sprays, mouthwashes, toothpaste, garbage bags, plastic wrap, carpet underlay, clothing, undergarments, athletic wear, toys, kitchen utensils, plastic products, chopsticks, pillows, sheets, towels, and slippers. None of these, absolutely none of these, need antibacterial properties. And you know this because the one that you would think would be the most likely to have antibiotic in it would be a soap or a detergent. But what do those do? Those dissolve the cell wall of bacteria and poke holes into the membrane or the capsule of viruses. So soaps are perfect on their own. They don't need antibacterial. And by introducing all of these antibacterial agents into your body, exposing your body to all of your bacteria there, and some of them are bad, because remember, your skin is protecting you, they can develop resistance. And then once they get resistance, they transfer it on to other ones, or they grow. And then, like you have an antibiotic resistant something on your hand now from using cleaning cloth, surface sprays, mouthwashes, and plastic bags and plastic wrap and kitchen utensils. And then you have a resistant bug here. And at some point it goes into your mouth accidentally. And now you have, an antibiotic resistant bacteria growing in your body, causing you problems. It's not going to work. So this one bugs the heck out of me, and it's one of my pet peeves. Sorry, but you don't need anything with antimicrobial or antibacterial properties at all, period. Hand washing is the single best way to do it. And how effective can chopsticks with antibacterial agents be in them? I mean, it's got to be a fairly low dose, right? But that still is enough to cause resistance in antibiotic organisms, but not enough to really protect you from anything. So, okay, you got it. Oh, here's the Amazon search I did. I just thought I would show you. 10,000 results, over 10,000 results for antibacterial. No, I wish they'd just stop that. Anyway, small amounts of antibacterial or antimicrobial agent won't destroy the bacteria. Some survive and multiply, and then these strains become resistant to antibiotics and disinfectants. So, yeah, bad news. We have met the enemy, and it is us. Yes, we are the ones who are overusing antibiotics, requesting antibiotics when we don't need them, using antimicrobial products when we don't need to, and we are creating antibiotic resistant bacteria. So we don't want to do that. So what can you do? Only use antibiotics when you're prescribed, and make sure you take them all. If you don't take them all, then those organisms in you can develop resistance to that particular antibiotic. Don't use leftover antibiotics. You don't say, oh, I'm feeling like I'm kind of getting a sore throat. I might have strep. I better take some of this antibiotic that my husband had a while ago. No, because there's not enough to kill all of the bacteria. And that means that they will be swimming in that antibiotic and can develop resistance, because it's not going to kill them. It's just going to, irritate them. So they make a gene that resists it. Right. And then also prevent infections by regularly washing your hands and avoid contact with sick people, etc. The common things. So the other thing, we want to save our own bacteria, right? So that's another reason we don't want to use antimicrobials. We have good bacteria on our hands, on our face, in our mouth, in our ears, everywhere. And we want that there, because by having lots of that, it's going to keep out the bad stuff. It can't, if you have, 100 bacteria on the tip of your finger, if you get one little bad guy, it can't grow, because all those other 100 are not letting it. There's no room to compete, because we have all our good bacteria there. So save our own bacteria. All right, so how do we prevent emerging infectious diseases? Those are some of the common ways, but here's the full slide. So we need to stop human activities or actions which favor zoonotic jumps. So that means stop eating monkey meat. Make sure we fully cook things. Don't transfer. Just have common sense about the foods you eat. And then I mentioned this with climate change and also deforestation and urbanization. Those are just common things that happen. The Amazon is losing something like 50,000 acres a day, and which means monkeys and all the other species in the rainforest have fewer areas to live, which means brings them closer to people. And urbanization. I have our cabin up in Pollock Pines. The forest fire happened, And so that destroyed a lot of brush that the bears were eating, the berries and the flowers and whatever. And so now they've moved into our territory. So the urbanization of the Pollock Pines area, there are houses there. And so the bears are like, cool, here's a trash can. Let me find that. Or even if they're not looking for that, they may be looking for berries or whatever in that area. All right, then there's the wildlife trade, which nets about $13 billion a year, according to the UN. There is illegal and there's legal trade. But when you, like, let's say you go on a safari and you're hunting an animal, and then you may come in contact, very close contact with that animal. You may come in close contact with fluids from their mouth, from their nose, from their blood. You may get a scratch just accidentally. So those can all also cause some emerging diseases. And then bushmeat, that's kind of, like I said, eating monkeys and other types of, wild animals, I guess you would say, should probably be curtailed. And then there are animal farms, where I think I mentioned the wet markets, like in China, where they grow wild animals basically in cages. So they might grow, they find a couple of foxes, they have the mate, and then their children are just grown in cages for food. And then, of course, live animal markets, and then additional domestic animals. Domestic animals are becoming more popular in backyards. A lot of people I know have chickens, so they can have chicken eggs. But most influenza viruses come from fowl, from chicken. So, that, not to say you shouldn't do that. I'm just saying that can cause an additional risk. So there is a society called the Infectious Disease Society of America, which monitors infections worldwide, and then they raise the alarm if they see something. It consists of over 2,800 infectious disease specialists. Most of them are North America, but some are global, and they help the CDC to track or look for emerging infections. And their specific goals are to detect new or unusual events, clinical diseases, identify cases when they're doing outbreak investigations, get information about these diseases, help connect members of the CDC to other public health, either another country or local public health. And then also they're trying to develop new methods for gathering epidemiological and clinical information as the world becomes more of a global landscape. We need to be able to track what's going on in Taiwan, as well as Russia, as well as Nicaragua and the United States, because all of those places have people coming to and from them. All right, so here's the United States Emerging Infections Program, which is held in 10 states. And this is the same kind of organization. They have doctors, specifically infectious disease docs, specifically looking and watching cases in the United States, trying to detect any new and unusual emerging diseases. And third organization is the National Center for Emerging and Zoonotic Infectious Diseases. And this organization tries to protect people from domestic and global health threats. So, similar to the CDC, but more focused on emerging and zoonotic diseases. So infections that spread in hospitals, foodborne, all the usual things here, deadly diseases, illnesses that affect immigrants, diseases caused by contact with animals, especially because they're zoonotic. So several organizations that are tracking, because this is expected to become a bigger and bigger problem. Air travel used to be restricted. Well, first we didn't have air travel. We didn't even have train travel. So, I mean, if we go back, we're way back. But if you think of, airline flights really taking off, no pun intended, in the 50s and then in the 60s, people were flying, but they were mostly flying domestically. They were within their country or in Europe, just, another country. But now definitely travel is global. It's worldwide. And it used to be very expensive. So up until about the 70s, to fly to Europe was about $1,500. So, and $1,500 is more like $5,000 now, back in 1974. But now rates are down, except with gas prices going up. But, basically rates are down, and so more people can travel worldwide, and they will take their diseases with them. All right, so there is a movement called the One Health Movement, and it was set up by the Wildlife Conservation Society. One Health is an organization that hopes to sustainably balance and optimize the health of humans, animals, and ecosystems. And it recognizes that all those systems are closely interrelated. And what they try and do is to help all of those populations, animal, human, etc., live in their area without affecting the other group. So giving everybody kind of their own niche in which to live, while also providing, things that they need. So assuring that there's food for animals, not feeding them, but protecting environments so that they will have food. And then also for humans, having clean water and food available so that they don't need to eat bush meats and other things like that. Climate change, they realize, is going to have a huge impact, and so they're trying to get ahead of that. So here it is, just a diagram of what One Health is, and it's how to achieve optimal health for people, animals, and our planet. So it's a collaborative effort among lots of different organizations, environmental agencies, animal health agencies, and human health agencies. And, they just look at kind of everything and try and help where they can. So how can you use a One Health approach? Well, I think this is important. Practice healthy pet habits. So you want to choose the right pet. You want to make sure you get the right pet before you bring it home, and that means doing a little homework. So, do you have kids under 5, or you're old? Are you an older adult? Do you have a weak immune system? Are you a pregnant woman? And then you want to avoid bites, scratches. You want to supervise young kids around pets or any other animals. I've mentioned, not feeding chipmunks in Lake Tahoe area. I've mentioned not drinking water from the ponds. There's a lot of ways that we can practice our habits and healthy pet habits as well. All right, so for pets, you want to keep it clean. You want to wash your hands. You want to scoop up your poop. You don't want to kiss your pets, despite the old wives' tale that dogs' mouths are cleaner than ours. It's not true. Dogs eat their own poop. Just saying. Be sure to take your pet to the vet as recommended regularly. And if you think they might be sick, take them, because it's unlikely that you will get it, but there's a possibility, especially with some of the emerging and re-emerging diseases. And then we also want to keep wildlife wild. So when you camp, you want to bring a bear canister or a bear bag to hang up your food, so that anything that smells, including sunscreen, that kind of thing, is not reachable by the bear. And the reason for that is because if they get used to eating people food, or people items, sunscreen, whatever, lip balm, then that's what they're going to try. When they smell it again, they're going to say, "Oh, that was good. Let me go get some more of that." So we want to prevent that. If you encounter a wild animal of any kind, you want to remove yourself from that situation. Back up slowly. If they're looking threatening, you want to make yourself as big as possible and fight back if you can. Anyway, but if you give them enough space and they know you're not threatening them, then they're usually going to leave you alone. Observe wildlife from a distance. Don't get close, no matter what. Don't feed animals. And then, of course, store your food and trash securely. And then keep your pets away from wild animals and dispose of waste properly. All these will help to keep wildlife eating and living in their own areas. And then leave what you find. Don't take anything from the forest, because animals there are depending on it. Just even like some branches, there may be birds that that's their hiding spot. And once it goes away, they don't have a hiding spot. They got to find a new one. So, and then also you want to avoid bringing in anything that's not native to that area. I know a lot of a lot of Europeans brought in a lot of different wildlife, not wildlife now, domestic animals and species of plants and animals. And you might have been through a state checkpoint, and they check there because if you're bringing in something like oranges and you're going into California where there's a huge orange population or orange growing production, if you're bringing in an orange that has a disease in it from another city, state, whatever, then that can transmit to that current population in your area. Also minimize your campfire impacts. Campfires can cause a lasting impact to wildlife if they get out of hand. So keep your fires small and not as smoky, no bonfires. And then again, use only down or dead wood, and burn all your wood completely. All right, here's some of our friendly animals that are up in the Sierra that we would like to protect. So do your best, and they'll do their best. All righty, that's it for now.